we can take a frog embryo and induce a particular electrical pattern somewhere in the body that we already know that pattern codes for make an eye. That's how the other cells interpret that pattern. It means make an eye. Very interesting in the sense that we don't have to say which cells do what. We don't have to say which genes you need to turn on. These are all micro level details. We don't need to worry about them because the material is competent. Just like when I'm talking to you, I don't need to worry about how your synaptic proteins are going to, you're going to take care of all of that, right? All I need to do is give you the prompts and vice versa. And we're having this amazing conversation, but our hardware takes care of all the molecular detail. And the same thing here. So we provide a bioelectrical pattern that says, make an eye here, and the cells make an eye. Now, the first thing that happens, it's interesting, the first thing that happens is there's a battle of worldviews that takes place. We inject a few cells, they tell their neighbors, let's make an eye. The neighbors actually say, no, we're supposed to be skin or gut, don't do it. In some cases, sometimes they win and sometimes we win. And so the goal of regenerative medicine is to be as convincing as possible so that you win 100% of the time. But in the cases where we are convincing, and we have amazing videos of cells like convincing each other to have different voltages and whatnot, they make an eye. And so what you've done is you've taken a bunch of cells that were going to be, for example, gut, and you've now pushed them to be an eye. At a very high level, I don't know how to build an eye. I don't know all the genes that have to be turned on. You do that. I'm telling you something at the level of organs. This is going to be an eye. The eye is of the right size. It has all the right layers to it. It is functional, right? So you can see out of these ectopic eyes. It's really, really amazing. And so that is an example of giving these cells a new goal. How do I know it's a goal? Because I did not micromanage you to do it. I was not there saying, turn on this gene, turn on that gene. I gave you a far off set point, by the way, in a wild space that no individual cell knows anything about. The anatomical space of organ structures, no individual cell knows what an eye is, but the collective does. And they stop when it's done. I don't need to be there to tell them to stop. They stop when it's done. And so this is autonomous goal-directed activity. It's a navigation of anatomical space. And so we can do this. And we can't make everything. We can make portions of the brain. We can make eyes. We can make, in some cases, limbs. We can make some other structures.